Hello everybody. This lesson is for Wednesday and Thursday. You're going to be doing covalent compounds. Okay, so now quick reminder, covalent compounds are a nonmetal and a nonmetal coming together. Okay, so what you're going to do is you're going to be able to write a chemical formula for covalent compounds using prefixes, and I'm going to give you a table right now in a minute. You're going to learn the rules for covalent compounds. So remember that prefixes can only be used for covalent compounds. Now here's your prefix chart. These prefixes can only be used if the very first element is a non-metal. So because nitrogen is a non-metal, you must use the prefixes. So the prefix for 3, look on your chart, 3 is tri. So you will have tri nitrogen, and what is for 2? Di. So you will have dioxide. Okay, you still have the same ending for the binary compounds as you do for ionic compounds. So oxygen will still be oxide, nitrogen will still be nitride if it's the last one. The first element will have the complete element name. Okay, and just a quick reminder on your periodic table, those stairs separates your nonmetals and your metals. So everything above the stairs is going to behave like a nonmetal. And everything to the bottom and to the left of the stairs will behave as a metal. Okay. Now on your chart that I gave you last week, remember these are group A's and these here are group B's. Group B's always have like a Roman numeral. Only the nonmetals, if the first element is a nonmetal, have prefixes. So now it does not count if you have something like magnesium chloride. Magnesium is a metal because it's on this side. Therefore, you do not use prefixes. It's a group A metal, so you do nothing to it. It's just magnesium chloride. Okay. The beginning must be a nonmetal. For example, a phosphorus with an oxygen, those are two nonmetals. That's a covalent bond. So when this first element is a nonmetal, that's when you can use your prefixes. Your prefix for 2 would be di, and your prefix for 6 would be hexa. So this would be diphosphorus hexoxide. Okay, so let's do a couple of examples. If I give you something like, let's say tribromine, bromine, or boron. Let's do boron. And let's do tetroxide. Okay, this prefix tells you exactly what you're going to use. This is a scientist's way of saying, I don't care what the charges are. I want you to use this many for boron. So tri is 3, so boron will have 3. And tetra, oxide is for oxygen. Tetra is down here, so I'm going to have 4 oxygen. Okay, this will be your chemical formula for a covalent bond. Now remember, covalent bonds share electrons. Whereas the last chapter when we did ionic bonds, they transferred electrons. Covalent bonds are going to share always. Okay, so you have two non-metals working together and they're going to share their valence electrons. Okay, let's do a different one. Let's do it in the opposite direction. If I give you something like nitrogen and oxygen, you don't have a number down here, so when you have only one, that's mono. This should say mono. For the first element, you don't have to write the mono, you can just write nitrogen. Now, it's not wrong if you write mono, but you don't have to. For the second element, however, you must write the mono. If not, it's incorrect. So this would be monoxide, because I have one nitrogen and I have one oxygen. This would be your chemical name for NO. Okay? If we need more examples, go ahead and feel free to ask me. You can stop this video and ask me through Zoom. Okay, so let's do a couple of examples here. I have one carbon, I have one oxygen, so it's carbon monoxide, and that's your total chemical name. Okay, here I have one carbon and two oxygen. So you have carbon, you don't have to write the monocarbon, but oxygen has two, so it's going to be dioxide. Okay, remember, IDE ending goes for the last element if it's coming from the periodic table, always. So oxygen would be oxide, nitrogen would be nitride, sulfur would be sulfide if it's the second element only. Okay, let's do the third one. You have phosphorus and chlorine, and you have one phosphorus, so it's just phosphorus, and you have three chlorine. Okay, so what's my prefix for chloride? This would be trichloride. Okay, for carbon and CCl4, carbon, my prefix for 4 is tetra. So it would be tetrachloride. Okay, now our last one, N2O. Di is my prefix for 2, so it's dinitrogen. And I don't have an oxygen number over here, so that means it's only 1. The prefix for 1 is mono, so monoxide. Okay, and that's it. Okay, so now to just wrap it up, a covalent bond, when you have two nonmetals coming together, if they both have an equal shared valence electron and equal electronegativity, that is a non-polar bond because they share it equally. They share the electrons equally. If you have something like, let's say, an ionic bond that's Na and Cl, the chlorine actually has a larger electronegativity than sodium. This is an ionic bond. They transfer electrons, where covalent bonds share electrons. All right? Now, because it's an unequal pool and chlorine is actually going to have a greater force, unequal means it's going to be polar. Okay? Okay, now, I know we've gone over the single bond, double bond, and triple bonds, but let's just recap and make sure that everyone's still okay. Remember, when you have a single bond going from nitrogen to carbon, you're going to have one electron on one end and then another electron on the other end. So if you have, let's say, sodium and chlorine, Sodium's going to transfer that electron to the chlorine. Okay, each bond has 2 electrons. So a double bond would have 1, 2, 3, 4. And a triple bond would have 1, 2, 3, 4, 5, 6. And that's how many total electrons either they are sharing or they're transferring. Okay, this pretty much wraps up part of what we did for ionic compounds, and this is also covalent naming and bonding. So if we still have questions, go ahead and stop the video and ask me during Zoom.